today we are going to do factoring. We're going to start with the common trinomial. And notice tri means 3, like tricycle. And notice there are 3 terms. So the first way we start is we list all the factors of the last term. Then we add or subtract the numbers so that we obtain the middle term, which is, this case, is a 5. So notice 2 plus 2 is not 5, 2 minus 2 is not 5, negative 2 minus 2. So there's no way to add or subtract a 2 and a 2 to get a 5. Notice 4 times 1 is 4, and 4 plus 1 is 5. So we're going to set this up. And notice if we put a positive 1 and a positive 4, if we were to FOIL this out, we would get that. And I'm just going to do it the first time or two so that you see if 2 check, x times x is x squared, x times positive 4 is 4x, 1 times x, and 1 times 4. And notice when I combine like terms, I get exactly what I started with. And that's the purpose of this, to put this in an equivalent form. And then later we're going to learn what to do with this and why you would even factor to begin with. So now I'm going to list the factors of 18. So the obvious is 18 times 1, 9 times 2, and 6 times 3. And we're going to add or subtract those terms to get a positive 3. Now notice in this case they were all positive, so that's slightly easier. So we have this. Can we add or subtract an 18 and a 1 to get a 3? And we can't. 18 minus 1 is 17, 1 minus 18 is negative 17, and so forth. Now we're going to go to 9 and 2. 9 times 2 is 18. There is no way to add or subtract a 9 and a 2 to get 18. 9 plus 2 is not 3. 9 minus 2, not 3. Negative 9 minus 2 is not 3. So there is no way to add or subtract a 9 and a 2 to get our middle term 3. That leaves us with 6 times 3. Now notice a positive 6 and a negative 3 give us 3. So we're going to set this up, and then we're going to put the 6 and the 3. Now notice we have to make sure when we FOIL we get a negative 3. So x times x is x squared. X times negative 6 is negative 6x. Positive 3 times x is positive 3x. 3 times negative 6 is negative 18. Now notice in this case a negative 6 plus 3 is negative 3, not a positive 3. So we want to switch it, and I'm showing you the check so you can see, you can figure out if it's right or wrong right off the bat. And notice we're going to get a 6x and a negative 3x, which gives us what we're going for, x squared plus 3x minus 18. Now again, this is not necessary unless it's required by your teacher, but I want to show you how this works so when you FOIL it out, you get the exact thing you started with. Okay, so now let's move on. Terms of 40. Okay, so 40 times 1 is the obvious. 2 times 20, 8 times 5. You're trying to get a positive 3, adding or subtracting. So 40 times 1 is 40, but you cannot add a 40 and a 1 or subtract to get 3. So we can throw that out. A 2 and a 20. Adding or subtracting. So 2 plus 20 is not 3. 2 minus 20, not 3. Negative 2 minus 20, again, not 3. Notice, 8 and 5. 8 minus 5 is 3. So that's our winner. So we have to have it's a positive 3. So notice 8 minus 5 is positive 3. And then if we were to FOIL it, you'll see you get the final answer. Okay, moving to the next one. We have 6 times 5, 30 times 1, and 15 times 2. Looking and adding and subtracting, I'm going to set it up because we know this is going to be for certain. And notice a 6 and a 5. Ooh, we got on the first try. Negative 6 minus 5 is negative 11. And again, if you FOILed this out, notice you're going to get what we started with. I'm crossing it out only because it's not required. Okay, moving on to our last two examples. Three times 3, 9 times 1, and right off the bat, to get a 6, 3 plus 3 is 6. So they all have to be positive. Now, when you have two of the same terms, it's most correct to write it this way, because that's the simplified version of that. And then our last one, this one's easy. 1 times 1 is 1. And notice, negative 1 minus 1 is negative 2. What a coincidence. And so we're going to get same thing twice. So that's x minus 1 squared. Okay. Now we're going to do factoring when the leading coefficient is not 1. Notice in the previous examples, the leading term was just a plain x squared. In this case, it is not. So this makes it a little more work. So here we are. So we know 2x times x is 2x squared. And we know 3 times 1 is 3, and there's nothing else this one could be, so I started with an easier one. So what we have to figure out is the 3 going to go here and the 1 going to go there? Or is the 1 going to go there and the 3? And so clearly, if we were to kind of FOIL this in our head very quickly, we would get 2x times x is 2x squared. 2x times 1 is 2x. 3 times x is 3x. No, and 3 times 1 is 3. Notice a 2x, the middle terms, and a 3x are not positive 7. So this could not be an option. So now we're going to go to the next example, and notice 2x times x is 2x squared. 2x times 3 is 6x. 1 times x is x. Notice a 6x and a 1x do add to the middle term, a positive 7. That is our final answer. These are uncomfortable at first because they're a lot more work. There are multiple ways of teaching these, some of them step by step, and it feels easier initially. But the problem is when you get to upper division math and algebra 2, pre-calculus, or wherever you're going, it's much more labor intensive versus looking at these and being able to factor them very quickly. So I strongly recommend hanging in there and seeing the pattern, writing out. Notice I wrote out all my options. So we know, here we go again, 3x times x is 3x squared. Now, we know 5 times 1 is 5, or 1 times 5 is 5. And notice these are very different because of that leading coefficient is a 3. So if we check the outer and inner, because clearly the first, 3x times x is 3x squared. So if we check the outer and inner, we get 3x, and 5 times x is 5x. And notice no matter what you do, adding or subtracting a 3 and a 5 will never give you our goal, our middle term, which is 14. So we know this could not possibly be the option. Now moving to the next item. Again, we notice the first is 3x squared. Outer, 3x times 5 is 15x. Now we're going to do the inner. Notice this is the check, this is the thinking. And some of you will get to the thinking and do it in your head much faster than others, and it doesn't matter in the end as long as you get it. And 1 times x is x. Notice, a 15x positive 3x times positive 5, and a negative 1 times x minus x gives us what we're going for, which is positive 14. This is our final answer. Last one. We have 4 times 5. We have 10 times 1. We have, what else? Oh, I'm sorry, 10 times 2. And we have 20 times 1. So we have a couple choices here. I'm going to start by writing out all the options it could possibly be. And if you'll go through the trouble to write out all the options, as annoying as it is at first, it really helps in the end to see the patterns and to get to a place that's quicker and faster and more efficient. So this could be a 20 and a 1 or a 1 and a 20. Because remember, when that term here, the first term, is anything but a 1, it kind of stinks. We could do 4 here, 5 there, oops, a 5 here, and a 4 there, or a 10 and a 2, or a 2 and a 10. So here we go. I'm going to check the outer and inner. Obviously 2x times x is 2x squared. So if we do outer and inner, 2 times 1 is 2x, 20 times x is 20x. And notice no matter how you subtract a 2 and a 20, you are never going to get a positive 3. Not ever. So that's not an option. 2x times 20 is 40x. 1 times x is x. And notice again, a 40 and a 1 will never add or subtract to a 3. Next one. We know the first 2x times x is 2x squared. Notice I'm foiling to check. 2x times 5 is 10x. 4 times x is 4x. Again, a 10 and a 4 will never add or subtract to a 3. 10 minus 4 is 6. Negative 10 minus 4 is negative 14. That guy's not going to work. 2x times 4 is 8x. 5 times x is 5x. Notice, a positive 8 and a negative 5 give you a negative 3. So 2x times positive 4 is 8x, and a negative 5 times x is minus 5x. And then I hope you notice, negative 5 times 4 is negative 20. This is our final answer. Now we're going to move on to difference of squares. I think you're going to like difference of squares. It is pattern based. It is very quick in general to see and to factor. So why don't we start with, x squared minus 25, y squared minus 49, m squared, n squared minus 121, and why don't we do, how about, I don't know, x squared minus 4 over 25. You know it's difference of squares. Let me erase this. You know it's a difference of squares when the same thing times the same thing will give you the outer terms, and there's a minus in the middle. And the factor pattern is x plus 5, x minus 5. And if you wrote x minus 5, x plus 5, when you FOIL it out, you get the same thing. So I'm going to show you the first one to check. X times x, we're going to FOIL to make sure when we FOIL it, we get the original back, because that's the whole purpose, is to put this into a form we can use, which you'll find out later how we use it. X times x is x squared. X times negative 5 is minus 5x. 5 times x is plus 5x. 5 times negative 5 is negative 25. These terms cancel, And notice you get the exact thing you started with. So that is difference of squares. So notice y times y is y squared. 7 times 7 is 49. And there's a minus in the middle, a subtraction sign. And so it's going to be as simple as y plus 7, y minus 7. If you didn't know, if you did, stop, sorry, come here, stop. If we did y plus 7 times y minus 7, you would get the same answer. It's identical. Because when you're multiplying, it doesn't matter which order you multiply in, it comes out the same. Don't bark, okay? Do you want to say hi? Come say hi to everybody. He's my big boy. There he is. No, he doesn't want to do it. Okay. Here, this one's a little tricky. M squared, n squared. Notice, mn times mn is m squared, n squared. And 11 times 11 is 121. And there's a subtraction sign in the middle. So it's mn plus 11. mn minus 11. And then this one's a little tricky because it's fraction. But notice, x times x is x squared. 2 times 2 is 4. 5 times 5 is 25. And there's a subtraction sign in the middle. So that gives us x plus 2/5, x minus 2/5. And that's difference of squares. And now for our last one, which is factor by grouping. Okay, let me put these on. We're going to do mn plus 4m. Oops. And the last one. Factor by grouping is easy to identify because there are 4 terms. So notice when we did the trinomial, anything x squared is going to be, I don't know, plus 3x minus 2, 2x squared, blah, blah, blah. That's the common trinomial. 2 terms with a subtraction in the middle and their perfect squares is difference of squares. And notice here we have 4 terms, so it's factor by grouping. So I begin by looking at the first 2, and notice you can pull out an m, leaving n plus 4 in the parentheses. And notice if we were to work backwards, m times n is mn, and n times 4 is plus 4m. Looking at the second 2 terms, they have a 3 in common. So that's going to become, if you pull a 3, 3n divided by 3 is n. 12 divided by 3 is 4. Now, noticing those 2 terms are the same, you know you did it right. So you're going to take these 2 that are all alone, slap them together, and then you're going to take the m plus 4, and that is factor by grouping. And if you were to FOIL this out again, you would get back to the original. Here, we're going to look at the first 2 terms, and we're going to see what we can take out that's in common. And you're going to hopefully notice here, a 2 and a 6 have a 2 in common, and they both have an f that I can factor out. So 2f times g is 2fg. 2f times negative 3 is minus 6f. We're going to look at the second 2 terms, and notice a 3 and a 9 have a 3 in common. 3g divided by 3 is g. Now I purposefully did this way. Notice these don't match. They aren't the same. Here they were. So I know I did something wrong. So now I have to go back and I have to look and notice if I pulled out a positive 3 times g is 3g. A 3 times negative 3 is a negative 9. These are now the same, so I did it correctly. I take the two terms that are all alone, and I smack them together, and I take the g minus 3, and that's the correct factorization. And now the last one, first two terms, they have an x in common. Notice x times y is xy. X times negative 4 is minus 4x. I look at the second two terms. Notice a 2 and an 8. A 2 and an 8 have a 2 in common. 2 times y is 2y. 2 times negative 4 is negative 8. These match. I know I did it correctly. I take the two that are all alone, smack them together, and I write the y minus 4. And that is patterns of factoring.